20 meters. So for those of you who watch ham radio and RV channels on YouTube, our guest this evening should not be a stranger. Steve KM9G from Temporary Offline and the Coffee and Ham Radio channels is joining us this evening. His channel is one of the most entertaining yet technical channels on YouTube. He covers complex content with ease and brings it to a level most hams can comprehend, except this one. His channel is a blend of old school ham radio and modern technology delivered in a no-nonsense manner, covering topics from VHF to solar power. He brings it well down to all his subscribers. Along with his technical knowledge, Steve is one of the most approachable YouTubers out there. So welcome, Steve. Thank you for your time for joining this evening and to talk about NanoVNAs. We're glad to have you, brother.
Awesome. You bet, John. It's great to be here. And I'll do the big reveal. Can you get me on solo on center screen?
Yeah, let me do that. Hang on one second. Let's see. Where's the solo? Make spotlight for everybody. That should do it.
All right. So I'm going to open this up. It's a shirt that John gave me, the Y-Car shirt.
Yep.
I'm wearing that tonight in honor of you guys. So I
Thank
helped out a little bit with the the ISS space station contact you guys did last summer.
Yeah, he was instrumental in getting his YouTube channel to rebroadcast it. So we had our channel going, the Air's channel going, and Steve's channel Temporary Offline. So
not that I'm special, but I wanted to help you guys out with some more visibility. And definitely, I'm always got a nod towards getting youth into ham radio, and what better way to do it than get to talk to an astronaut during school.
Absolutely.
Awesome.
So John dropped some links in the chat, and I don't know if everybody who showed up after he dropped the links can see them.
I just redropped
them again. So what I want to do is I want to show you, I have a NanoVNA case, and this holds the H4 model, which has the big 4-inch screen, which makes it a little easier to see. But we're going to do it on the computer screen, and John's actually got control of the computer. What we're going to do is we're going to go through a calibration, and we're going to go through actually tuning an antenna with it. I've got a coil loaded vertical. I'm using the Radioddity HF009 antenna. So it's a center coil with an extendable whip on it. So the coil does your coarse tuning and the whip does your fine tuning. After we get done the benchtop stuff and talking about the stuff, I'm going to actually take the camera and the laptop and go outside where the antenna is. And John's going to run a sweep, tell me what to do. I'm going to do it. He's going to run another sweep to see what kind of change it made. And that's the really cool thing about the NanoVNA is you can hit this thing and see where you are. And the NanoVNA has, I don't know, 10,000 features. And the two that I use the most are the Smith chart and the SWR sweep. And if you've ever used like an older MFJ antenna analyzer where it just tells you where you're currently resonant, this one will tell you an entire band at a time. So the screen that we were sharing earlier is a sweep of the 20-meter band, and you can see the SWR is 9-to-1 at the bottom of the band, and it gets a little bit better, 8.4-to-1 at the top of the band. And so we're going to get that all dialed into shape. But if you haven't ever used a NanoVNA before, and if you ever use a NanoVNA in front of anybody that has, the first thing they will do is yell at you about how you haven't calibrated it. So John's going to be the hands. And then one of the reasons why I like this case, I didn't make the case, I just found this thing on Etsy, and it's a really neat little 3D printed case, and you get your call sign and whatever. He's got these for the NanoVNA and the Tiny SA, if you've seen that. Inside the case, there's a little trapdoor false bottom, and inside there is where you have all of your calibration standards. And so it's really hard to lose your parts, which is why I like it. And so we got to do a calibration for open, short, and load. And I didn't hear that. What was that?
I think Jack was stepping away from his computer. Let me just mute him real quick. Okay.
So you can go with the open calibration standard. Some people argue that using the open calibration standard is going to actually make a difference. But if you look, I don't know if the camera is going to be good enough to pick this up. There is a center pin on the SMA connector for the short, and there's not one for the open. So obviously one of those is shorted center to shield, and the other one is not shorted center to shield. And then you have one that's a different color. So this one's kind of silver in color, and the normal one is kind of brass in color. So the one that's silver in color is actually a 50 ohm load. And this is not like power rated. It's just enough to show the NanoVNA and its, eighth of a watt signal or whatever it actually puts out, that there's a 50 ohm there. And when you get into testing things, you want to try and remove as many things as possible. So really the best way to test this, and it doesn't matter unless you're trying to do like high-end scientific research, the best way to set this up would be to take the calibration standards and put them all the way at the end of the coax so that you're testing the antenna. I'm going to put them here right at the instrument, right at the NanoVNA, and I'm just going to assume that my coax is good and it's 50 ohms through and through, and I don't have to worry about it. And for the kind of stuff that I'm doing in terms of getting an antenna in play, that's fine. But really, you want to try and calibrate out all of the problems. If you're using a bunch of adapters, if you've got a bunch of stuff in the way, if you've got a couple of short coax jumpers or things like that, you really want to get as close as you can to what we call the device under test, the DUT, the DUT, to cancel out all of the stuff before that, the different coax jumpers and adapters and things that you would use. Not always possible, but just keep that in the back of your head. And for checking out an antenna, we've got a 50 ohm source, we've got a 50 ohm transmission line, and then we hit the antenna with a 50 ohm connector. And from that connector forward, it's no longer 50 ohms. So close enough for ham work, close enough to get the job done. So John, if you can run into the software, somewhere in there, you see the calibration button lower left?
Yep, I just hit it.
And this is not the world's fastest laptop that this software is running on, so it might take it a second to pop up. It hasn't popped up on my end. There it is.
I hit it harder.
And yeah, hit it harder. So somewhere on there is so I'm going to put the short on.
Okay.
So let me put it on first, and then I'll tell you to hit the button. Okay. So it's the one without the pin. And then I just screw it into the S11 port. And if you look at it,
should that be the one with the pin shorted?
Yes, you're right. Thank you, John.
Okay.
Doing stuff live is always fun. If you look at the front of your VNA or any VNA device, it's going to have a couple of ports on it, and it looks like it says S11, but you actually pronounce that in the scientific community as S11, and it's the number of measurements that you're taking. This is a one-port measurement, and then if you did S21, it's a through measurement, so it's going to be from port 2 to port 1, so S21. And if you do what we're doing today, which is an antenna analyzer, it's from port 1 to port 1. So it's a S11 measurement. So I've got the short plugged in, John. Go ahead and hit that button.
Okay.
And then there's it's calibration assistant. Now I found the button. At the bottom of that box, we've already done the short, it's fine, but at the bottom of the box, you see calibration assistant.
Hang on, get out of here.
You're too far down.
Too far down
now. Yeah. So the
box
that you were in.
Yeah.
There you go. So hit that one, and it's actually going to walk us through the process. And you can do this right from the screen of the NanoVNA if you're out in the field doing field work, but it's harder for me to show you this 4-inch screen and deal with camera reflection and everything. So we're doing the software here. So hit OK, and it's going to walk us through the process.
Okay.
Place the short. Done. Hit OK. And it's doing some magic. It's doing a little more in-depth magic, too. Look at that trace go across the screen.
Yeah. Okay, now put your
uncalibrated. The short did.
Okay. And now you got put your open standard on, Steve.
All right, the open is on and locked down.
Okay, ready to roll.
If you really get serious about this, there's actually an SMA torque wrench so that you don't over tighten or under tighten these, because there is actually a torque spec. And then your SMA connectors have a lifespan on them too.
Okay, and then we got time to put the load on it.
And the load is on.
And we're loaded.
And see how you got that 1-to-1 match at the bottom as the graph is going across? All right, and so now, read this real close. If you wish to continue and perform a 2-port calibration, which we don't, so do not press yes, so just hit apply. There we go. And so that's the one gotcha. We're not doing a through-port measurement today, so we don't need to do that. If you are using this out in the field or using this on a regular basis, you can now save this calibration. And one of the other things that you might want to do, say you're a 20-meter guy and that's the only band you use, set your axis across the bottom here to be the 20 meter band that you want to look at. Run your calibration for the 20 meter band, which it was set to 20 meters, 13.965 to 14.385. So it's got a 10% pad on it. And we've actually calibrated it for the 20 meter band today. I need, John, I need my SMA to SO239 adapter. So got one of those. And again, we could have calibrated that out, but we didn't. What were you going to say, John?
I'm going to close the calibration window now.
Awesome.
Okay.
So if I save that calibration, I now don't need to go do that again until I change things between what I'm testing and the NanoVNA. So if my coax goes bad and I actually had calibrated out my coax, I need to update that saved configuration. I'm not going to save the configuration today. I'm just going to connect this up to an antenna. So again, what I have as far as all the stuff between point A and point B, just oversharing, doesn't really make much of a difference. I have a 1 foot coax jumper going to a 2-inch SO239 to SO239 chassis mount through plate to get through the top of my workbench, underneath my workbench. And then I have a choke that's wound for HF from ABR. They told me there was a difference and they're smarter than I am, so I took their word for it. I've got one for HF and one for VHF, UHF. All of this coax is RG58. From the outside of the RV, I have a RG58 run of 28 feet that goes through another choke that's at the antenna side. So I'm actually choking at both ends of the feed point. So at the shack side and at the antenna side. So the coax should really not be acting as a counterpoise or a radiator, a radial or something along those lines. I have 3 radials. I want to say they're 5 meters long. And then I have that center loaded coil vertical with the whip. And I want to say the whole thing is probably, I'm guessing here, the whip is 7.5 feet tall and the coil is at shoulder height. So 13, 14 feet tall as a guess to kind of give you guys a ballpark. So if you sweep, John, we should be able to see just how bad that antenna is or isn't tuned to start with. And down at the bottom, you've got the ability to do a sweep band in that box, and it's set for 20 meters with a 10% band, 10% pad. So a little bit more at the bottom, a little bit more at the top to give you some understanding.
Okay.
And then 5 centimeter, you just changed the band.
Yeah, Christ. I'd say 20 meters. There we go. All right. Set band sweep.
Yeah. And then just close that box out.
Close the box out and now hit sweep.
So we're still at 9-to-1. Actually, we're a little bit better than 9-to-1 now that we've calibrated the unit. And we'll probably get down to 8.25 at the end.
Okay.
Close enough. I was going to say something. I totally forgot what I was going to say. Okay, I'm going to go outside and we're going to keep on working.
Okay.
All right. So we're going.
I'll entertain the troops, I guess.
Oh, I'll still be on camera.
Oh, that's right. You're bringing the camera with you.
I'm bringing everything with me.
There you go.
This isn't his first time streaming mobile there, John.
Yeah, that's true. I got to see it in action on Saturday.
All right, so there is the field in which all my antennas grow, which is out in front of the RV. And the sun is in just the right position for this. You guys picked the perfect time of day.
Look at that. It's backlit and everything.
So there's the, where is it? There's the ABR coax. You can tell because it's got that green shrink wrap on it. There's the choke hiding in the grass. The 3 different 5-meter ground radials going out in 3 different directions. And then there is the coil on the antenna, which is, this is supposed to be weatherproof. So this coil is all internal. And then there is a nice little whip. And the weather cooperated with us. It was raining like crazy yesterday. I thought it was going to be all soaking wet outside.
Oh.
And then this has an internal, let me set the laptop down on the ground. This has an internal slide mechanism. I don't know how well you can see that with the sunlight in the way, but there's a little button there.
Yeah, I can see it.
And I just moved that up and down. So I moved it up 1 inch, I guess. So if you rerun the sweep.
Okay. Rerun the sweep. SWR is coming down. The top of the band, or the bottom of the band is 8.43. And you're getting close to about 7 7/8 on the high side of the band, Steve. So you're gonna
All
have to
right.
push that up a little bit higher.
We're actually going to have to push it a lot higher. So what I do with this, your adjustment range, if you can see my fingers there, is about that much. So that shows you how much coil contact that I have. And the farther up you run this to the top, the less coil you're using, and your coil's adding inductance. There's a little tiny bit of radiation that comes out of it, but most of your radiation comes out of the whip. And then this coil part here is really just a big inductor that you're adjusting. So what I'm going to do is I'm going to put it all the way up to the top. And then when John's finished changing colors,
Oh,
we'll
you
run
can
it
see
again.
that, huh? Okay, go ahead.
Oh yeah,
Tell me,
not my first rodeo, right?
good to sweep.
Yep.
We're rolling.
Look at that.
Yeah. It jumped down there quite a bit.
All right, so it also changed the scale when it was done. That's pretty cool. So one of the things that also is going on here is I'm in the near field of the antenna. So I'm actually part of the transmission circuit. So I'm going to move back over to the picnic table. Get me out of the radial field. Where's my radial? My rule of thumb, and I don't know if I'm smart about this or not, but my rule of thumb is to be on the outside of the radials whenever we do this. So John, if you run that sweep again, we should see the SWR change now that I'm not part of the antenna anymore. It's going up a little bit.
Yep. Looks like you added some capacitance to it, Steve.
Well, I do bring a certain capacity to everything I do.
That's that magnetic personality.
Right. Well, that would be inductance if you want to be a ham about it.
True, true.
All right, so I'm going to stand and stare directly into the sun when I do this. I'm going to pull that down a little bit because I don't know that I can actually make a good connection at the top of that coil. Try it again, John.
Coming again.
Oh, there we go.
Oh boy, look at that. That's usable.
So what I did
right
was
there.
I had it maxed all the way out at the top of the coil, which I think probably just missed the coil and screwed things up a little bit. But here's one of the cool things that I like about this. If you guys have used like an ICOM radio before and you've done the SWR where you push the button, 13 times or whatever, and it gives you a little chart, sometimes it'll say like 3-to-1 across the band, and you don't know if the antenna is too long or too short. So if you look at this chart tells me that the antenna is actually too long.
Right.
And the reason why I know that is because the curve is going that way. I'm actually backwards. So the curve is going that way, stage direction, stage right, stage left. So you can kind of imagine that the other half of that curve is going up farther down the band. So the bottom of the screen is 13.96 megahertz. So I'm going to put a number on it just for illustration's sake. 13.96 is where you see it. Let's say SWR is resonant at 13.7. And then the curve starts to go back up again, and it'll start to look the exact opposite of what you see on the screen. 14.3, so let's say 13.5, 13.4 is where you'll see the other end of that rise. Does that make sense?
Yes.
So that means that looking at this, the antenna is a little too long. So what I need to do is add a little, push that coil up to remove some inductance. So I'm going to push the coil up. And just a little tiny bit in this case, because coils are what we call high Q antennas. And if we run it again, yeah, see how that's moving over to the right? That's where we want it to go. So I actually moved it too far.
A little too short.
Yep.
About halfway between that.
So when we were talking about high Q and like John said, a little too short. Try it again, John. What happens is just a little teeny tiny movement.
Now the other way.
Yeah, and I'm actually not paying a whole lot of attention to how much I'm moving the antenna. It's more about demonstrating that moving it makes a difference.
Yep.
If you go down, might be off the screen. I don't know. Can you scroll the entire screen down? There should be a button that's off screen that's like configure. Oh, display setup, lower left.
Got it.
So scroll down, displayed charts, which is off the bottom of that box. See how it says S11 Viswar?
Yeah.
Change that over to Smith's chart.
So chart. There we go.
S11 Smith chart. Okay, close that. We're in the same range. We're on the same antenna, and you can see that little curve. And it shouldn't change any. I think it was good.
Yeah.
But doesn't take long to run it. One of the cool things while that's running, one of the cool things that you can do with the software, the NanoVNA itself can only do 100 data points or 99 data points or something like that. The way that the software does it is it does those 100 data points, and if you tell it you wanted 1,000 data points, it'll just do 10 chunks. It'll break it into 10. It'll do 100 per each 10. 10 times 100 is 1,000. And so you can get a lot more data on your screen at once. So what this is telling me is that we have too much capacitance because we're below the center line. And I'm going to go move it. I'm going to move it down some more to give it more inductance, I think. I'm going to move it down 2 inches.
Yeah.
Run it again, John. We should see that little dip go up if my intelligence is good. Woo. Yeah, there we go. So now it's above the equator. Anything above the equator is inductance. Anything below the equator is capacitance.
Right.
And if we were really smart, we could actually read that chart and figure out what it's trying to tell us. And let's say it wants me to add 37 microhenries of inductance. I could go put an inductor on there, run the sweep again, and if that was what my math told me, it would be dead on where it belongs. So now I've moved it. I've added more inductance, and it's showing on the inductance side of the Smith chart. So above the center line is inductance, below the center line is capacitance, and then you see those circular rings that go out. And I can't remember without looking it up because I don't use it for that purpose that much, but John just found it. That's your 50 ohms.
That's your 50 ohms right there. Yep.
And if you go left or right, so that would be, so you went, pick one. There we go. You went left. So what is that, 75 ohms?
75, 100, 125, yeah.
Yep.
Or thereabouts.
So if your radio was a 75 ohm radio and you had 75 ohm coax and you had a 75 ohm dummy load attached to the end of it, you clicked go, it should be right dead
there.
center on that dot. And if you switch the system out to a 50 ohms, it's going to be on that dot. Thank you, Vanna.
You're welcome.
I'm going to add some capacitance and see what we can do.
Hey, John, let Matthew back in. He switched devices.
Oh, for crying out loud. Okay, I'll let him back in.
All right, run it again, John.
Yep. It's
running.
Yep.
It didn't move much.
Nope.
I think it got longer. The brown line got bigger.
Yeah.
Go do it again.
Steve's getting his steps in.
I am. My phone's on the desk in the ham shack though, so it's not counting. Do it again. Oh, we moved it.
Yep. Still.
All right, I'm gonna move it just a little bit more.
Okay.
And-
Real hams use Smith charts to tune an antenna.
That's right.
Oh, you can, sure.
Like I said, he's a blend of old school and modern technology.
Now, if you actually had a manual tuner and you had, what did they call it? I was at the 4 days in May, and the guy took a part and put it on his workbench, like a transistor or something. He put it on his workbench,
Mhm.
and he ran it through. He had a word for it. Now I can't remember what the word for it was, but he ran it through his entire matrix of whatever. Did you already run the sweep? It's still running, or it's done?
I did not. I ran it.
Okay.
It moved it up a little bit.
I can't remember the name that he used. All right, do it again.
All right. Shit.
Oh, there we go.
Yeah, I started to run it when you were in the near field. Sorry. My finger got excited.
I just added that capacity.
I race run it. There you go. Is it jammed up? Steve, did we lose you? I think we lost him.
Yeah, I'm here.
Okay. You froze
It was
for a
you.
second. Oh, it was me?
I'm blaming you. Yeah.
Okay.
So what he did was if you imagine your MFJ Versatuner where you've got your inductor tap in the center and then you've got your 2 capacitors on the outside and each one of those has little tick marks on it.
Yeah.
He's the kind of guy that would sit down and plug it into a known standard and then tick mark 1, 12 picofarads. Tick mark 2, 13 picofarads. So you can
Yeah.
actually go through this and know what to do and then dial it out.
Right.
Some of your auto tuners, even the ATU 100 will tell you this. If I was to put the ATU 100 on this and hit the button, it would tell me how much inductance and capacitance it used.
Right.
And then I can go modify the antenna and take the tuner out and be in tune.
You actually don't have much reactance in this system, Steve. You got
Yep.
about 19.9 ohms of reactance, but you've got only 22.7 ohms of real resistance.
And you're reading that from somewhere. Tell everybody
Yeah,
you're
where the
reading from.
marker's at. I'm looking at the center of the band
Wave your mouse around.
right here.
I can't see the mouse anymore.
It's at marker 1. It's the first box off of the sweep control.
Okay.
Yeah.
So if you look at this screen, your top box on the upper left is your sweep control.
Here.
And then the markers are the 3 sets of boxes right 1 column over from that. And wherever you put the marker, you can pick a red one, a green one, a blue one. You can change whatever colors you want.
Yeah.
It'll actually tell you the impedance and series capacitance, series inductance, parallel reactance, etc. And you can see the gain and a whole bunch of other stuff. So I mean, this is more than an antenna analyzer. This is a vector network analyzer, and
Right.
this is one of the things that you can do with it is use it as an antenna analyzer.
Right. And then down here it gives you the SWR and what frequency the minimum's at. So where it says S11, you're looking at 2.329 to 1 at 14,387 or 384, excuse me. So
So if you go back to display setup on the lower left, you can change that back to your SWR chart.
Yep.
And then we can try and get this antenna tuned up a little bit
let's
better.
see.
You're down there. It's at the bottom.
It
Where
says
is it?
S11 Smith chart, displayed charts.
Oh, I see. There it is. Okay. I lost it there for a second. My apologies.
Yeah, I think you need it.
Down.
Yeah, second from the bottom.
There we go.
There you go.
And then
Right,
if
so
you
we're at-
really want to have some fun, go to sweep settings and do continuous sweep. And then you can see how Steve's messing up the
Oh, do that. Yeah.
SWR while he walks into it.
Okay. Sweep setting.
Should be towards the top. Continuous sweep.
There it goes. And let's go hit sweep. All right. So now it's continuously sweeping.
That's actually updating pretty quick too. All right. So I'm going to move into the near field.
Yep, it dropped.
Yep.
And then I'll move out of the near field.
Yeah, it's moving around. Sure enough.
All right. So another one of the tricks you can do with an antenna like this is you can remove radials. So I'm going to pull one of them off and we'll see how that looks. Once I get out of the way.
Yep, SWR went up.
So there's one and we're at 2.75.
Yep.
Let's take off another one and see how that looks.
Ooh.
So they make a difference.
Yep.
And then Rolly taught me this one. Rolly says that wire on the ground is still a resonant length of wire on some frequency and is still interacting with everything. And the whole scale changed. I don't know if you guys saw that, but the vertical scale changed. And we're now at 3.6 to 1.
Yeah.
I'll put those two back on. It's kind of misleading when the scale changes when you're looking at it from a distance. So
Right.
there's probably a way to fix that too. All right. Radials are plugged back in. And
Yeah,
the
scale
just
changed. Yeah, we're down below 3 SWR now.
All right, so my antenna is too short. So I'm going to move that slider down a bit
That's what she said.
every damn day. All right, so if you're in person with this antenna, it looks like a ruler is engraved into it. Oh, it liked it when I was there. 8!
Yeah.
8, no way.
Yeah, something bad happened there.
Yeah, I moved it very far. There we go. And so because it's got that ruler engraved on the side of it, if you are constantly setting this up in your same soil conditions, your same general area, you can make notes. 2 inches from the top is where I'm resonant on 20 meters.
Yeah. You're still, you're a little bit long now.
So shorten it up a bit.
Oh, that's much better.
So now we're usable, but I can still do better. And you can spend all day doing this, or you can get on the air and make contacts.
Yeah, right there, it's a usable antenna. A little better usable now. Depending on where you're going to be in the band.
So if you look at the bottom, it's 14.1 megahertz. It looks like the lowest dip is 14.3. So Maritime
Yeah.
Mobile, here we come.
Yeah. And that's what it's saying. 14.305. It's 1.343 to 1. So that's a very usable antenna right there.
Now, John, you might know this better than me. Modern hams with their fancy VisWAR detectors and whatnot really want to get this at 1-to-1 on a specific frequency, but 1-to-1 on a specific frequency doesn't include your reactance.
Right.
So somewhere on the screen, it tells you about reactance.
Yeah. So your reactance right now at the center
39?
at 14,300, right? That's because we had that marker 2 at.
Yep.
Your reactance is 4.77 ohms, and that's capacitive. So you're just above resonant there. So somewhere in there, you're going to be, somewhere around that frequency, a little higher, a little bit, probably a little bit lower, you're going to be resonant. Now, the SWR is going to still be off because you're dealing with a vertical here, right? So when you talk about vertical antennas, they're native, but not the resistivity, right? The real resistance in the antenna is going to be around 36, 37 ohms. So you're still going to be about 1.4, 1.5 to 1, even if you were resonant, right?
Mm-hmm.
Because resonance is a definition of zero reactance, meaning there's no stored energy in the system. It's releasing all the energy.
So while John was talking, I remembered the word I was hunting for earlier. It's characterize.
There you go.
So we just characterized this antenna a little bit. And if I was actually taking real notes, and what you would want to do with an antenna like this is set it up like I have just outside the house at a picnic table or something, and go through all the bands that you're interested in, 40, 20, 15, 12, 11, and know what you need to do to get it really close. And I just kind of moved a little bit, and you saw I added some capacitance to it.
Yeah. And the thing about it is, if you have an antenna like this and it's going to be set up in the same location, you can even take some nail polish out there or some paint on it and paint where your markers are, right? Just like you would on a manual tuner or an amplifier for your bands, for your antenna that's always in the same place. Obviously, if you move, ground condition change, SWR, and all your measurements are going to change. Now the question is how much they change.
Yeah, I went out to White Sands National Park. White Sands National Park obviously is full of sand, and it's my understanding that the RF ground is below the surface of the soil, the surface of the sand. And I didn't have enough ground radials to get the job done when I was out there, and actually failed at Parks on the Air activation. I had to go back again later and do it with more ground plane beneath my antenna. And so I actually used the truck. I've got a 4-door truck extended cab with a 8-foot bed, and that actually makes a pretty good ground plane for 20 meters. Lots of metal under the antenna. And then I was in Louisiana, and I had the exact opposite problem. There was sandy soil, but there was a lot of foliage, a lot of big leafy green vegetation around, and I had trouble there too. So it gets you close, and then you ham your way through the rest of it.
Yeah, I'm trying to
John,
see. Yes.
Stop that sweep. Go to sweep settings, and you know how you could set it for wider. You might be able to see more of the curve.
Yeah. Well, I think I'm looking at the curve. I think I know where this thing is resonant at. And that's what I was trying to do with that marker, and I won't think it won't let me change it while it's sweeping. All right, stop.
Once you change the sweep settings, don't you have to calibrate it again?
No.
No.
It depends on how far you go. If we move from 20 meters to 40 meters, you really should,
Well, yeah.
but it'll be fine.
But
mean,
you know how in the sweep settings, you could do the 20-meter band, or you could do 20 meter plus 10%, 30%, whatever. You could widen it.
He's messing with markers now for some reason.
Yeah.
I'm trying to find the point where it's resonant at.
I think
He
you
wants
can
to
just
do it the hard
click
way.
on the screen too. You can just click on the thing,
Yeah.
I think.
14.268, it says on the S11 on the bottom over there.
Well, that's minimum SWR. I'm looking for
Oh,
resonance.
oh.
So, yeah, so that's 5. It's somewhere right in here. Yeah, somewhere around 290, somewhere in that neighborhood, I think. Yeah, it's a little further out.
I know what I like to do is how T.O.'s got it set up here to where the NanoVNA is in the shack, and he can monitor it remotely from a computer. So I'll hook it up to one computer, and then I could remote into that computer with a tablet or phone and monitor it, so I could go out and adjust it, and not have to run back into the shack and out.
Oh. It's a little
That's
higher.
What I love about using the Nano, because then you can get it. What's the SWR right at the radio, not at the antenna.
Mm-hmm. And if I didn't do this, I actually did a video where I ran back and forth into the shack and out of the shack while I was doing all this stuff, and it's not easy. I know on like a dipole, you can tune it at, eyeball height, and it's 2-to-1, and you kind of know that as you raise it up, your SWR is going to get better the farther away from the ground reflectivity. So after a while, you start to learn tricks like that.
I didn't know that.
Yeah. Yeah, I can't find it right now, but it's somewhere between 300 and 325, somewhere in there where it's resonant at.
So it's really similar to the being in the near field, but what's happening is your signal is going in all directions from your antenna, and on a dipole, some of those directions are down at the earth, and then they're bouncing back off the earth into the antenna. So I don't know if you guys have ever tried to look at an SWR chart on a 2-meter radio inside of a hotel room. The floor and ceiling are full of rebar. Yep. And so you get a lot of signal reflected back at you that isn't actually what you would consider SWR, but it's very similar to SWR in concept. So your SWR is your standing wave ratio, and it is the difference between the signal you put out and the reflection coming back. The reflection doesn't have to be bouncing back inside of the same wire. It can be bouncing back from the room around you. And so if I go over to the antenna, I'm going to be inside that near field. So the signal is actually bouncing off of me back into the antenna.
Right.
Which is another actually interesting thing to bring up, is if you're trying to use this, and this will work on 2-meter antennas, if you're trying to use this to look at a HT antenna, you holding the NanoVNA, the same way when you hold your HT, you're the counterpoise to the antenna, you're the counterpoise to the NanoVNA testing the antenna. So you have to take that into account as well. You can actually see it. You can move your hand in and out of proximity, and you can see the SWR change as you're doing it.
Right. So yeah, just one of the big takeaways from this is, SWR is one thing, resonance is a whole other animal, and a lot of people conflate the two, where you'll have they say, oh, my antenna's resonant because I have a 1-to-1 SWR, but that may not necessarily be true. It's a combination of the reactance and the resistivity of the antenna. So resonance means you have no reactance, so there's no stored energy, and all of it goes out to the antenna and out to the air. So just an aside there. If you put a signal powerful enough into an antenna that's close enough to metal, it will cut itself to resonance.
Yes.
So
cool. So one of the other things that we could probably do, I don't know how much more time do we have?
Well, we got about 10 minutes or so.
Okay, you see that TDR, time domain reflectometry?
I was looking at that to see if you wanted to play with that.
Yeah, so I'm going to unplug the coax from the antenna, and this will tell me how long from the NanoVNA to the end of the coax.
Yeah.
the coax is, or it'll tell me where the break in the coax is. So I'm assuming I've got 25 plus 3 plus 1. Let's go, 30 feet. And if you run the TDR, it might be able to tell me.
Let's see.
30. What does that say?
It's telling me 77,000 feet. So
Inches. 77,000. Oh, 77,000
feet and 3.4 inches.
3.4 inches.
Yeah. What's
So
your
we have
velocity?
to-
What kind of cable is that?
It's RG58 from ABR. Let's see if it's on the label.
Yeah.
Might be. You have to take into account the velocity factor. Is what
Yeah,
John's
so I'm
doing.
looking for it. Yeah, AFE. There's
Oh, it's 50 foot of coax, John.
okay. So it's 6.6. So let's see. I don't know where it starts. Sweet, maybe. No, that's not where it's at.
Estimated cable length 551 meters. It's still trying.
Yeah, it's bringing it down. It's looking at it. Yeah, it's not right. Hang on, I got something set wrong here. Bear with me a second. Let's see, 54 AU. This
Verify
is-
any other assumptions I got wrong.
Let's see.
OG58 CU.
Help. Yeah, we've got something set wrong here.
But this is good for finding a break in your coax, which
Yeah,
I
it
had a
absolutely is.
couple of squirrels chew on my coax, and when we got it all dialed in, it told me exactly where it was, and I went and dug up the coax, and it was true.
Okay.
So while John's fooling with that, the other thing you can do is I've got an attenuator, and I can see, where the roll-off curve is on the attenuator by running what's called a log mag instead of a Viswar scan or a Smith chart or something along those lines, and you can get all of that dialed in. So I can tell where the filter rolls off. If I wanted to tune a cavity filter for a repeater, I could use this.
No, it's not. Something's not right. I'm not getting what I think it should be doing. I've got something set wrong here, Steve.
All right. Well, we weren't planning on doing this. I just figured we'd kill some time.
Yeah, you can get, your length of your coax. You can figure out velocity factor with these things for your coax. They're an amazing tool for the money you pay because, they're
$50
pennies.
-ish.
Yeah, they're pennies to what you normally would spend on a true full size VNA. I mean, you're talking 4 and 5 digit machines, right?
And people will give you a heartache about, it's not a bird or it's not a Siglent or a Tektronix or anything like that, or it's not an old HP. But honestly, your 1980s, 1990s HP, 60-pound luggable is probably hasn't been calibrated in 20 years. I'm not making fun of anybody who's got one that's been calibrated. Don't go down the wrong path there, but probably just as good as this thing.
Yeah,
I would love to see a head-to-head.
I'll always look at it this way. It's close enough.
Right.
Exactly. For what we're doing.
We're not doing scientific measurements down to the 1/1000th, right?
Yep. I just got myself on the air and made a whole bunch of contacts and had a fun day.
Exactly.
Yeah,
Well-
they're great for tuning bandpass filters on amps too.
Are you good for some questions, Steve?
I sure am.
All right.
I don't know that I have any answers, but you can ask.
Anybody got questions? Unmute yourself and have at. I know there's got to be somebody other than my dog.
So that antenna is pretty broad, man.
It's not bad for a coil antenna.
Yeah.
Yeah. The
Their
Q isn't
other
as
one
high
that
as
they
I thought
offered
it
was
would be.
pretty narrow.
Now this is on 20 meters, and this antenna will do 60 meters.
Mhm.
So as you get closer to 60 meters, it's going to be a lot more broadbanded.
Broadband or narrow banded?
Narrow banded. I'm sorry,
Yeah,
I said that
yeah.
backwards. I was
Yeah.
thinking.
Yeah, I was thinking you'd probably end up with a higher Q the lower you went.
Yeah. The other thing you can do is you can add more width to it.
Yeah.
Which will unnarrow the Q.
Right.
You can also add more coil to it if you had coils that attach. This is 3/8 24, but it's upside down compared to other 3/8-24 antennas. So if you had like the Chameleon antenna, that's 3/8-24 male threads at the bottom into a 3/8-24 female. This is 3/8-24 female threads at the bottom into a male.
Okay. So turn the coil upside down.
Yeah, just go to a hardware store. Yeah. Turn the coil upside down, and then all your adjustments are upside down, and all that fun stuff.
Yep. Cool. All right. We have any more questions?
More radials, lower SWR?
To a point.
To a point, but also you can tune this antenna by adding or removing radials too. And I don't mean by SWR. I mean like you can get a band that you didn't have before. If I really went crazy, like an elevated radial, 130 foot long, I could probably get this thing on 80.
Yeah.
And you know, if anybody's interested in looking at the NanoVNA up close, let me know and I'll bring it to an open house one night and we can sit around and play with it in the open house. I'll bring a laptop and actually I set up the laptop at the desk in the clubhouse, the front desk, to handle the VNA, so we can plug it into the laptop and look at it on the TV if you wanted to.
Yeah, and this antenna's been out in the rain because the coil isn't closed. This antenna's been out in the rain for the last 2 days, and it has rained all day and all night the last 2 days. It's still dripping wet as I'm taking it apart here.
You got the arc set up out there?
I do, yeah.
Yeah. Cool.
I put a link to Tio's video reviewing that antenna in the chat if anybody's interested.
Yeah,
this one is out of stock currently. They're going to have stock in June. I've got a really good relationship with Radioddity, so I have some insider information for you. They're going to have some stock back in June. Thanks. I'll remember that. Anytime you reach out and need help on your channel, I'll remember that. And then they're going to have a sale in August. They're having their anniversary sale. They've been in business for like, I don't know, more than 10 years. I don't know the exact number.
Cool. All right. Anybody else with any questions? All right, Steve, we'll let you get back to it, brother. Thank you so much. It was wonderful to have you on board with us here tonight.
Yeah,
anytime you guys need anything else, I'll try and figure it out and help you out.
Great. Fantastic.
We'll catch you on Coffee and Hams next.
Yep.
All right, we'll see you.
See you guys.
Thank you so much.